Oh, hello everyone. So for the next 30 minutes, I will share about some research in robotics in ITRI. And the title of my presentation is Shaping the Future of Smart Manufacturing, ITRI's R&D Strategic Deployment for Industrial Robots. My name is Shu Huang. I'm currently the Technical Director, especially in Robotics, ITRI. So just a quick the answer for the previous questions. That now in robotics we also have some collaboration in Canadian companies. Some of that is in about haptic interface collaboration. We also like proposal in a Global Star or Eureka project, something like that. So in robotics we have many international collaboration projects going on. So that's some information to share with you. Okay, the topic of today's presentation is about core technologies in robotics, and I will share with you some current development and also the future innovation applications. And in the end, I will share some like our future perspective and beyond. So to start with, we all know that the robotics is a hot topic recently, and especially with the help of artificial intelligence, we think that the robot really can change the future, not just in industrial applications, but also in service domains. So as we see that AI robot it's a really key for the flexible manufacturing because of the reliable workforce. And of course, with the introduction to the robotics, deployment of robots in factory, we can increase safety for human labors. And in the long term, of course, we can reduce operation costs. So that's the forecast for robotics. And the other aspect is that if we can see the forecast in the future, every year the forecast is that service robot has greater opportunities than industrial applications. And we believe that in the current trend of our generative AI, we can really see that the service robot is a potential opportunities. Okay, so let's move to the ITRI's core robotics technology. The robotics division established in the year of 2005. So up to now, it's 20 years. Among these years, we have accumulated lots of foundation technologies and also research. And the first focus on the from 2005, we started in the service robotics. At that time, we have developed cleaning robots, security robots, tour guide robots, etc. And we established the core human-robot interaction technology. And as from 2010, and with the help of the Industrial 4.0, our focus shift more on the industrial robot. That includes robotics hardware design, and also for autonomous mobile robots. Our focus is still on the control algorithms and our controller, which is the heart of not just the industrial robot, but also the AGVs. And with the 2015, that's another digitizing trend. So we developed our own simulator to enabling digital twin, cyber physical systems. And as for the recent years, of course, the artificial intelligence and the robotics solution for manufacturing are our focus. As you know that ITRI is really encouraging the spin-offs. So if you have enough knowledge and you see the opportunities in the market, of course, ITRI encourage people or the team to really devote it to the industrial. So robotics is not an exception. So we have until now 3 main spin-off companies. So in 2017, we have a group doing the exoskeleton startups free bionics. And for 2018, another group focusing on the robotic skin, enabling industrial robots to transfer it to collaborative robots. And for this year, also another spin-off, Holo Robotics. That's a team which they provide operating systems for industrial robotics. And the vision is that make robots as easier as possible, like iPhone, so everyone can leverage the robots in factories. Okay. And the focus quick glance that EVP just introduced. So the focus first is the controller itself. So we can see we have various control capabilities, including position, velocity, force, and human-robot interaction control. That's the basic of the robotics. Later on, we have our own simulator, and that's currently can generate data for AI models to train. Vision is also important. So we have especially the vision-guided robots and also a lot of AOI inspection in applications in factories. The work includes metal works or a lot of master works in factory, including drilling, painting, grinding, polishing. And this we provide real solution for the industrial. And the next is the mobilities. So before it's automatic, autonomous mobile robots, and now it's mobile manipulators. Later on, we will have humanoid or legged robots. So first, I would like to share with you some innovative design. So for the robot hardware, we have a detachable joint system. As you know that we can have industrial robot, we can have mobile robots, but the very fundamental unique could be a joint. So if we can have this all-in-one joint, people can easily assemble joints to different kinds of robots. That enables this kind of legged robot or humanoid robots, especially when we need a customized applications, we need a customized robots. This all-in-one joint is a real good solution. So we can have a video. Users can easily assemble by hand this detachable joint to their own need. So if we can have a 4-axis robot arm or 6-axis, or even in the future, we can make more joints to have a dual arm robots and also the mobile platforms. That enables the various kinds of application. Another advantage is that in case of a repair or some broken joints in the factory line, we can easily switch a joint. So we can reduce the downtime and also quickly repair the manufacturing. Okay. So another thing is that ITRI actually includes a lot of different laboratories. We have laboratory focusing on the information and the communication, and also a laboratory for smart sensing, and a laboratory for biomechanical. So it's a really, really good opportunity that if you work in ITRI to have collaboration with people or talents from different fields. So for example, sensors are very important to robotic system. So we have a smart sensor laboratory center that can provide the sensors we need. For example, MEMS microphone, inertia, IMU sensor, 3D sensing, or force sensing. To co-work with this multidisciplining lab, really enabling this future technology. So that's a great benefit to work in ITRI. And our robotic system, this is a concept for robot cell. If we want a robot to be used in factory, it's better to have a really all-in-one unit solution. So this is one example that we use robot as a centric of the machine in integrated simulator. So this can be seen as a robot operating systems. We can easily control up to 4 manipulators in a solution. And for different applications, we use the robot cell controller as a sentry. Together with the digital platform, we can easily perform different machining works and for different work pieces. As you can see, this is a really cross applications. So we can use robot cells as a unit to introduce this kind of solution, robotic solution to different work in the factories, including grinding, polishing, painting, welding, and different materials like composite materials. This is an example for welding applications. So this is a really great opportunity and really huge requirements from the factory where we can introduce our robotics system. Okay, not just for industrial applications. So the core technology we accumulate can also be used in service domain. So these are a brief introduction that we use our robotics technology for different domains outside factories. So for example, the logistics or the warehouse transportation, we use a mobile arm robot and autonomous forklift to solve the problems in the factories where the workpiece and the metal parts can be transported within the factories. And for service domain, we have used this kind of autonomous mobile robots in convenience store or shopping malls to help the people to refill the goods or to check the goods. Not just for the shopping mall, we can also introduce the hospital cleaning. So we have this kind of cute robots doing the floor cleaning. And the core technology includes the self-navigation and map building, and of course, obstacle avoidance. And later on, we introduce more human-robot interactions, so the robot can answer questions for clients or patients. And of course, in airports, train stations, or other business field, we can use these cleaning robots. And one unique application is the medical applications. Our high precision robot technology and also imaging system can not only be used in factory or manufacturing products, we can also use that to save lives or to improve the medical procedures. So this is one example where the surgeon perform spinal surgeries. In this procedure, high accuracy is really required. So our robotic system, together with the global locational positioning system, provides surgeons with really high accurate assistant device for spinal insertion. The surgeons, of course, they take the fully responsibility in the end, but this device provides really good guidance and also information for the surgeons so that they can perform better procedures with less stress. So this is the example for robotic system to do the spinal insertion. Another one is for another beyond endoscope surgeries. So that's what we called soft robotics. So we have a robotic endoscope. In this case, it's for lung cancer. So we can have this really tiny part of the tube with the diameter only 4.3 millimeters, together with the navigation system, and we can help this tube endoscope to move around within body to a really precise location. And this is a automatically delivering system where we can easily use it for biopsy or drug displacement, or we can even upgrade if there are something need to be removed. This kind of surgery is that we don't need to cut up your body, we can use the natural of orifice in your mouth or nose. So it's really the future of medical applications. Okay, for the last 10 minutes, I would like to share with you some artificial intelligence to enabling robotic systems. So as we know that the ChatGPT and also generative AI really demonstrate the capabilities in programming and also in human-robot interactions. So we can leverage this kind of technology or model to robotics. In ITRI, we have foundations with mechanical design, electronical design. We have this smart modular joint. We have the controllers. We can easily build up a dual-arm humanoid robot as a platform. And then we can also easily make mobile manipulators to move around in the environment. And that's the robotic hand. We also believe that this really dexterity of the hand is important. So we also integrate a group starting from the mechanical design, sensoring technology, tactile skin, and also electronic miniature motor actuators. Altogether, we can have this robotic hand for future use. So in ITRI, we have good foundations and mechanical parts. And next, we will introduce the artificial intelligence and training models. So we can easily adapt a large language model to robots. For example, for cleaning robot, for service robot, interactions or GPT-based natural language interfaces now already introduced to many kinds of robots in service domain. And we, on top of that, to build a next step, which we called behavior model. In order to make the robots to be useful, the generative AI can be a part to generate various kinds of behavior. But that kind of a behavior requires a lot of data to train and also a lot of sensory, including vision system, motion system, tactile sensor to train the robots for behaviors. And ITRI has the information and the communication technology lab. We also leverage the biggest training server in Taiwan, so we can really use to recreate the virtual environment, use the great computational power, not just in ITRI, but also the government, Taiwanese government provides to have a better, faster training for the behavior models. And also, the world model is important. The robot need to know the environment, not just as image or obstacles, but really the semantic information of the object. So we need to even build up a larger world models. So this also now we are on the the process of doing that. And that world model can be used not only for robots, but also for drones. So we can also, as far as I know, and also autonomous driving systems. As far as I know that we already built up some map and really the model for the ITRI campus. So maybe in the very few in the end of this year, we will see that many robots walking around or moving around in ITRI campus. And this world model can be used to train behaviors and also interactions, even the tasks for robots, really fast and really useful. So the control of robots now it's shifting from model-based, like traditionally kinematics, dynamics, to a really new area, like the learning-based. So we have to establish this behavior model, world model, to enabling this kind of training-based, learning-based robotics. Together with the modules and hardware design, we reduce the gap of sim to real. And very fast, you can see the progress in this kind of learning-based robotics. Okay. So the last part I will showcase one closed loop example that we cooperate with the artificial intelligence and also robotics. So the scenario would be like in the kitchen, no, in the living room, where you just sitting on the sofa, and how a robot can really perform or service you in this way. So the first, that's the black diagram. I hope some of you can really understand. The first one is exploration. So if everything good? Okay, I'll just continue. If there's something wrong with the Teams, please let me know. So we're starting from the exploration. So the world model or the robots need to understand the environment, which we called it the technology of scene understanding. Then any kind of any human or users can use natural language way to interact with the robots. So you can just talk or discuss the task with the robots. And with some verification, human in the loop, or confirmation, the robot will generate a task that we use a VL and visual language model. And in the end, this confirmation of task can be validated and then deploy or validate in a real system in real actions. So that's the video, including all of that. So the first is the scene understanding. So this place is a cafeteria in ITRI, one of the cafeterias, very beautiful. And you can see that the robots just move around with their RGBD camera to reconstruct the environment. For your case, maybe the living room or your bedroom. So the robot once recreate this environment and together with the large language model or visual language model, the objects can be recognized and can be reasoning. So the robot can know the exact environment of this location. That's what we call embodied AI. So you can use text interface just like ChatGPT, or you can use voice interactions to talk to robots to really ask the correlation or the thin understanding of this environment. For example, you can ask the robot to identify the location of a coffee machine or the microwave on the table or even the vending machine. So they also can have the understanding of the relationships of the objects. For example, the vending machine is on the left side of the microwave, and the coffee machine is on the right side of the microwave. With all this information, thanks to the generative AI, we can easily make a robot to understand this environment. So the next step is to generate behaviors or navigation actions for robots. So the last video, we combine all these scenarios. So you see the first is visualize everything. So this is the model of cafeteria. We used a real images and recreate the virtual mode. And this is the text interface that we ask the robot to identify the location of the vending machine and the coffee machine. You can see that the bright lights it's shining on the overlay on the position, which gives the confirmation that the robot really understand and know the exact location of the object. We can also ask like GPT to ask what the object on the table. It will like reply an apple, a plate, microwave, exactly, and with the location. So we have coordinates of these objects. Then we can ask the robot to perform tasks. For this case, we ask the robot to pick up an apple and put it on the plate. With the information of the coordinates, the trajectory or the behaviors can be generated by robot. In the end, we deploy this on the real manipulators in cafeteria. And the robot can grasp an apple and put it on top of the plate. So all this demonstration, unlike the traditional way, we really reduce the effort of engineers to coding, to write state machines or to write control for robots. the generative AI really helps a lot. And with the establishment of the word model, behavior model, and even a language model, this really accelerates this integration for robots that can really provide services in everyday work. So we are still on the process integrating this, and now we have a really good team working on artificial intelligence and mechanical robotics and also sensory information, etc. So we believe that the progress for this trend will be really fast. Okay, so that's mostly the introduction for robotics, and I really look forward that good talents or the robot lovers that they can join our team to create the future. And yes, hopefully that give you some insights or ideas of how robotics team or how robotics developed in ITRI. Of course, I'm happy to answer some questions if some of you have, but anyhow, you can use messages or emails to contact our HR in later. So, okay, welcome everyone. That's my presentation today. Thank you.